Assalamualaikum and hi everyone. Today we're going to show you tutorial on the variable charts for the control charts. Okay, so for this question we need to determine what kind of chart is suitable for this question. Okay, here it talk about the toothpaste factory and they give us information on the weight of the toothpaste. Okay, so they have taken 6 sample lot, and each sample have 5 sample size. Okay, so here they give information on the A2, D3 and D4, and since this is measurable in ounce, so we know that the suitable control chart for this data is variables. Okay, we have two types. We have variables and attributes. So variable is for the measurable in which they have units, but for attribute is more on the okay, not okay, either it's on the defect. Okay, it's a numbers. Okay. And then they ask us on the determine the UCL, the upper control limit, the lower control limit, and then we need to develop the control chart, in which this case we need to develop the X bar chart and R chart, and then we need to conclude if the process is in control or not. Okay, the first step here. The first step is, okay, so it's a variable, so we answer the first question here. And it's because why? Because it's measurable in ounce. And the first step is to find the X bar. What X bar means here is the average of the 5 tube here. Okay, so you have to do for sample 1, 2, 3, 4, 5, and 6. So after you've taken all the average, then you need to do the sum, because you need to calculate the X bar. Bar means that the average of average. So for this case, we have the sum 35.71 and we need to divide by 6 here. So we have 5.95. Okay, next, we need to calculate the R bar. Okay, what is R bar? Okay, first, what is R? R is the range. Okay, so range is maximum minus minimum. So for this sample, the maximum is 6.34 and then the minimum is 5.23. So we minus to get the range, so it's 1.11. So we have to do for sample 2, 3, 4, 5, and 6. And then we have to sum all the range. Okay, since we need to find the R bar, so 3.09 we need to divide by 6 because we have 6 samples here. So we get 0.52. Since we already calculate the X bar, and then we have all the information on the question, and then we need to find the upper and control limit of X bar. These are the formula. Okay, X bar plus minus A2 times R bar. Okay, so for the upper control limit X bar, we put all the information here into the formula, we get 6.25, and then for the lower control limit, it's going to be minus here, so we have 5.65, and then we proceed with the upper and control limit for the R chart. So for the R chart, the upper control limit is D4, okay, from here D4 is 2.11, and then R bar, we found out that is 0.52, we get 1.09, and for UCL, it's D3 is 0, so it automatically becomes 0 here. Okay, so we have all the information. First we need to develop the X bar chart, in which we have the upper control limit, the lower control limit, and also the control limit is X bar. And then for the R chart, we already have the upper control limit and the lower control limit, and also for the central control limit. Okay, so first we develop the X bar. Okay, for the X bar chart, remember this is our calculation that we done prior. And then for the first thing is you need to set the scale here. Okay, so since it's we need to know what is the upper control limit, the low control limit, and then this is the X bar. So what is this? What we need to plot? Here is the value of the X bar for the sample size 1 until 6 that we have calculated earlier. So we plot all the X bar here, and then this is the X bar value in which 5.95 for the central control limit, upper control limit we calculated earlier, 6.25, and the lower control limit is 5.65. So what can we conclude from this? Okay, since none of the x bar value is exceed the upper and lower control limit, we can say that the process is in control. So it's okay. Okay, now we need to develop for the R chart. For the R chart, okay, so we need to develop here the scale, okay, and then these are the sample size number. And then again, what do we need to plot here? This is the R value that we calculated in the table, remember? So we need to plot for sample 1, 2, 3, 4, 5, and 6. And then don't forget for the central control limit, we have the R bar in which is 0.52. For the upper control limit is 1.09, and for the lower control limit is set to 0. So what we can conclude from here, since there's one of the sample is above the upper control limit, so we can say that the process is not in control, so it's not good. Okay, so we need to do something wrong in the process, so we need to investigate and to solve what are the problem. Okay, and we need to make sure it won't go beyond that. Okay, so for the conclusion, because we need to read X bar chart together with the R chart. So these are the condition. Let's see if you find that the X bar chart is in control, but the R chart is not in control, so the overall process is not in control. So we need to do something. We need to investigate, we need to solve, and to make sure the process is smooth. And then what if the X bar is not in control and the R chart is in control, the overall process is still considered as not in control. Okay, and what we're looking for is that both X bar chart and R chart must be in control so that we can conclude that the overall process is in control and is in a good condition. So X bar chart need to be read together with the R chart so we can make the conclusion for the overall process. Okay, thank you.